A heart-shaped tree standing in between human nature and the nature we see. Wouldn't you know it now? Life's got a funny way of showing us how. I see you standing there listening.
Hello, hello, hello. Adam Fleischhacker here, helping you unify narrative, math, and code. Today's problem involves us looking at data from two spinners. Here they are. The spinner on the left will reveal something called the winnings multiplier, and the spinner on the right will reveal the maximum amount of winnings. And contestants to this game show spin both spinners and they get the product, winnings multiplier times max winnings, as their winnings to take home for the day. And in this case, the winning is $24,000. Okay, so let's bring our spinner story into VS Code, into the coding world. You'll notice links in this script, and I put links in the show notes to the code as well as the data we're going to use. The first thing I will Alt-Enter through is just some packages and some functions that I want to make available in my session. I'm not going to discuss those. You can look through the code yourself. And then I'm going to get the data. And the data is available at a URL, and we use CSV read to get the data in. And here's what we have, a data frame, 200 rows. So we have 200 observations of winnings multiplier and max winnings. You can see the first row, 40% winnings multiplier, 40% of about $24,000 ends up with $9,571 or $9,571 in winnings. So this winnings column is just the product of the first two columns. And then I'm going to add in this story because we're going to want to map color to columns in our data. So in order to show you the breadth of types of mappings, we want both continuous data. We're going to use color for the winnings column, and we're also going to use color for this happy flag column, where the story is, I'm only happy if I win above $20,000. I get to pay off my debts. If I'm below $20,000, I'm broke and not happy.
Looking down, shining on me, trying to show me how. Just takes a while, you should know this by now.
So now we encounter the first piece of code where we make a visualization. We're going to use the @width macro from the data frames meta package, just so when we pick columns from our data frame, we can use this symbol notation and it will automatically recognize those as our columns in our plotdf data frame. Scatter is a Makie function, or a Makie plotting function, and the first two arguments are positional arguments, with the first position being mapped to the x coordinate and the second position being mapped to the y coordinate. So we map data to x and y coordinates, but we didn't map anything to color, any sort of data to color, but we get blue dots by default in Makie. I'm not thrilled with the defaults. My y-axis doesn't represent my story about spinning for $100,000 up to $100,000. My x-axis is not bad. It's showing a range from 0 to 1 of the winnings multiplier. So we won like 60% of $40,000, I think, before. So we would be a point around where my mouse cursor is. These blue dots we're going to make dependent on our data, the color of them. But anything that's not dependent on data, that won't change no matter what the data looks like, I encourage you to map in a theme. So I will Alt-Enter on this definition of a theme. Notice that there are some figure attributes we changed, like font size, some attributes of the scatter plot, including the default color map. This is used for mapping these dots to continuous data as the default. We actually won't use Viridis, we'll use a different color map, but I show you this because in contrast to when we map color to something like happy flag, happy or broke, then color becomes an axis attribute and a palette within that. So again, I'm showing you these within the theme. We're going to override them using Makie attributes. So we see definitions for two components of a figure in Makie, the overall figure attributes, scatter attributes, axis attributes, including limits of the x-axis, which will go from 0 to 1 for our winnings multiplier, and our y-axis will have go from 0 to 100,000 for our max winnings. I hate the format of scientific notation, so We will change the ytick format using an anonymous function to get commas. I will label my axes. Again, these are all attributes of the axis. We can have attributes of a color bar. You'll see what that is later, and attributes of a legend. Just note color bar is used for continuous mappings of continuous or sequential data to color, and legend is used for when you map color to discrete attributes in the data like happy flag. Alt entering through set theme applies these theme attributes to the various Makie plot components or figure components, and then in line 42 I can now show you the plot with the nicer theme. These blue dots in the figure came from our axis palette definition in the theme. So our first color was blue, and as we add more layers using this scatter exclamation point notation, which means add to the existing figure, we'll add an additional point in purple. And the reason I know it's purple is because purple is going to be the second color, and the third time when I run line 46, it should add a point in pink. And I alt enter through that, and then alt enter line 47 to see our current figure, and we see the purple and pink dots get put onto our existing figure. So this blue, purple, pink, we scroll up, is exactly this blue, purple, pink. This cycle of colors in the palette gets initiated every time you add an additional layer of points to the plot, but sometimes you just map color to an existing column of continuous or sequential data in the data frame. For example, we could map our color of points to our winnings, our total winnings. Let's recall plot df. I'll just control enter on plot df. Here, our winnings column, which is winnings multiplier times max winnings. We can map color to that and press alt enter. And the color of the dots we see now is dictated by this default Viridis color map as a scatter plot attribute, or an attribute of a scatter plot.
Until you learn to love yourself, the door is locked to someone else. I'm just as damaged as you are, scattered to
If we're going to take control of our mapping from data to a color, we need to understand both continuous or sequential color scales and categorical color scales. If we click on this link and go to this color schemes website, you'll notice that there's a catalog of color schemes. Looking at the first color scheme, for example, the algae color scheme, you can see it would be good for mapping to sequential data, where low numbers could be this lighter green and then high numbers could be this darker green. We're going to prefer to use scientific color schemes, so I'll click on scientific. And the one we're going to use in this video is the Batlow color scheme, because it's really good for mapping human perception to changes in numbers. So there's uniform change in both color and lightness as you move left to right along this color scheme. This color scheme is good for continuous data that doesn't have a center. Sometimes if you look at the Barak color scheme, the center is white. You can imagine this being good for data that you want to map like altitude, where 0 actually means something. So you put a 0 as white, and anything below that altitude goes from light blue to darker blue. The depths of the ocean would be dark blue, and the tops of the mountain would be this dark brown, green, or whatever color that is. If we scroll down, we will find some more color vision deficient friendly schemes. So the Batlow scheme is color vision deficient. So we can be friendly in our plots to people who might have red-green color blindness or other issues. And then when we use discrete data, we will use some of these schemes. You can see the MK12 scheme has 12 different colors, and they're easy to distinguish from one another, and we will map those to categorical data. The color schemes we just saw on the colorschemes.jl website, our package help documentation, are available now to us within Julia. If we alt enter on line 58, I can see the Batlow color scheme. This is for sequential data, and the thing to know about color schemes in Julia is that they're indexed from 0 to 1. At least the continuous color schemes are indexed from 0 to 1, with 0 being the darkest of blues and 1 being this brighter pink color. If I index into the Batlow color scheme using this notation 0.1, 0.5, 0.9, I will get basically 10% a color from 10%, a color from 50%, and a color from 90% along this spectrum. The key to mapping data to color is to compress the data to be between 0 and 1. And once that data is standardized to be between 0 and 1, it's very easy to pick a color associated with each data point. If I run line 60 showing you the Viridis plot, this was the default color plot by Makie. You'll see we'll come up with different color maps later. Comparing 3 colors from Batlow to Makie, the 3 on the left are Batlow colors and the 3 on the right are Viridis colors. For our categorical color schemes, like the MK12, Alt-Enter on line 64, you can see I get my 12 discrete colors associated with the plot. And if I want to index into these, I just use integers. 1 will be this maroon, 2 will be this green, 3 will be this pink, and I'll prove it to you by running line 65. I get maroon, green, pink. If you want to pick your own colors for a discrete color scale, go ahead, use this notation. This is from the colors.jl package. If we look at their help documentation, they have named colors, and you can see all the named colors in Julia, and the way to access them within VS Code is to use this colorant and then a string representing the color name. So this will be my discrete color scale will be orange, purple, and cyan. And if I Alt-Enter, it automatically printed those for me, but in line 69, I can also index into that array of colors and get my orange, purple, and cyan.
There is no light, but don't give the ghost an inch tonight.
Okay, so let's finally map some data to a color. I'm going to Control Enter on this plot DF and remind you that we are going to map this winnings column to a color. So winnings can be anywhere from 0 all the way up to whatever the maximum winnings in this column is. In theory, it could be 100,000, but that's not what we see. We're going to take all these numbers that are in the thousands and map them to numbers between 0 and 1. That is our strategy. So when we look at this transform function or command, we're going to create a column called winning index that uses standardized from the stats base package and takes this column of winnings and makes all the numbers. The minimum number will be 0 in this column, the maximum number will be 1, and everything else will be put appropriately in between 0 and 1. Then, once we have our index, it's easy to get a color. We just index into our continuous color scheme, and that will create, or this line will create a new column called sequential color or sequential color, and that will store the actual color that we want every point to be. So I run line 73, Alt-Enter, and you can see down below I get a winnings index where if I have very small winnings like $3,300, I get a number close to 0. And if I have larger winnings like 27,000, I get numbers closer to 1. All these indexes get mapped to a color on a red, green, blue scale. And in fact, if I go down here to the terminal, we can say, show me those colors. So I created a data frame called seqdf, and the colors themselves are in a column called setColor. Press Enter, and here's our 200 observations of winnings. We know that pink is high, so look, we had some real strong winnings at the end there with the pinkness, but these are our 200 observations. If we look now to plot our scatter plot where we map color to winnings, we're going to use this column of data, this sequential color column. It's called an array attribute, and say color for each corresponding observation of winnings multiplier and max winnings. We're going to specify the color exactly. And we did so by looking at this winnings column, converting from winnings to winnings index, and then winnings index to color. That is our mapping. But as far as Makie is concerned, we're just going to tell Makie, hey, use this color. Always destructure, or it's helpful to destructure your Makie plots into figure, axis, and plot for further manipulation down the road. So I will do this Alt-Enter here, and we can now see our plot. This looks like the Batlow color scheme, with highest winnings being in the upper right and lowest winnings being in the bottom left. Now, a legend, if you want a legend for what colors mean what, Makie uses for continuous mappings of data to color something called a color bar. And we'll insert this color into our figure here to the right of it. That's row 1, column 2. We're going to insert the color bar into a newly created grid position at this location. And we have to tell the color bar the exact mapping that we told our data frame up above. One is that the color map we're going to use is Batlow, and we use the symbol for Batlow, and we also need to specify the limits of the axis. What number of winnings is 0 mapped to, and what number of winnings is 1 mapped to? And that's all determined. This extrema function will get us the high and low. If I just Control Enter on the extrema function, you can see the smallest I won was $328. The most, or winnings in this observation, was almost $43,000. These two things tell the color bar how we mapped from winnings to color. So we Alt-Enter on that and Alt-Enter on our figure, and we get this nice color bar where pink is closer to 40,000 in winnings and blues are under 10,000.
This could be so easy if you could see it through my eyes.
As opposed to winnings, which could go anywhere from 0 apparently to past $40,000, we're going to, let me Control Enter on plot.df here, remind ourselves that we have this happy flag here that is happy or broke. So there's just two values, happy or broke. How would I take these strings though and map them to numbers? Well, the easiest way is the way we see in line 91 and line 92. So what line 91 does is create a new column that creates a categorical array of happy flag. So instead of each one of these being an individual string, every unique value in this happy flag column will be assigned an integer value, our index. And to get into that index, we're going to take this new column we created, happy flag C, and extract the refs field from it. So the refs field will be the integer representation of these strings. So let's just Alt-Enter on this block here and take a look at discdf or discrete df. And you can see happy flag C was created. This is a categorical array. It looks just like my string array here, but underneath the covers, there's this index component, which will now assign 1s to every broke and assigns 2 to happy. Well, isn't that convenient? We get an integer index of all discrete values. And we know with an integer index, we can take a color scale and index the color scale, or index into the color scale, and take advantage of this. So, and we do in line 93, we go into my discrete color scale, which if you recall was something silly, orange, purple, cyan, and we're going to get oranges and purples. One of these is orange and one, I assume one is going to be orange. So broke will be orange and happy will be purple. Let's see if I'm right. So we actually say specifically using an array attribute color, each one of these points we assign the color. We took complete control of this situation. We're not we own our mappings, which as a grammar or graphics person, I like to own my mappings. So I Alt-Enter, and yes, indeed, orange is the number ones, or the broke fields, and purple is the happy fields. Now say we want a legend for this discrete mapping, these categorical scales. Well, we can't use a color bar anymore because a color bar is really meant for continuous mappings. When we have discrete mappings, we use a legend. And the best way to create the legend is manually, telling the legend exactly the mapping we did to come up with these orange and purple points. So let's look at this code. So legend df goes to this data frame we just created, discrete df or disk df, and then selects two columns, the my color column and the happy flag categorical column, right? Which is really, just think of this as the labels associated with these colors. If I then say, give me the unique combinations of happy flag categorical, broke or happy, and my color, I am just left with broke being orange and happy being purple. So let's just look at that a second. I'm going to comment out these three lines so we can see what select and unique does, right? It just gives me a 2x2 data frame with my two colors, orange and purple, and broken happy, the labels I want to use for those colors. And now this last bit of code here goes row by row in this data frame. There's only 2 rows, big deal, and creates a new column called mark element. And I think I'll use a symbol name just to be consistent. It's going to be a new symbol, mark element. We use a mark element function or marker element function from Makie and give it 3 attributes. The color is going to be the color of the my color column, orange or purple. We need to specify that our markers are circles. We didn't take ownership of the mapping of data to marker, but by default, circle is the first marker. Note this little weird notation, this caret and then the parentheses. That's because I'm within the @chain macro, and when you're within the @chain macro, it thinks all symbols refer to columns in the data frame. I have no column called circle in my data frame. So if you want to refer to symbols outside of the columns or outside of the columns of the data frame, you need to use this little caret and then parentheses notation and put the symbol inside. And then marker size, I like big markers, so I'm going to say 16. So my legend shows bigger circles for me. And then we alt enter, and we have this nice data frame where we have colors, the label for each color, broke or happy, and the specific marker element associated with that color. And then we can plot that into the axis legend. So this axis legend command puts the legend right into your plot. AX refers to the axis up here that we defined in destructuring our creation of the scatter plot. LegendDF.markElement, that is the data frame column of these 2 marker elements. One is an orange circle and one is a purple circle. And here we use the array command because Axis Legend doesn't like these categorical strings as labels. So if I just run Control Enter on this array, happy flag, C, that's my error. There we go, happy flag C. So I got to go back up here, happy flag C. All right, let's run this again. So if I look at Control Enter on array happy flag C, you can see I get my 2 strings broke and happy. And now Axis Legend command creates that legend inside the figure, and line 112 fig allows me to see it. Notice that the title was an argument passed to the Axis Legend function. Position :RT stands for right top. That's where our legend went. And horizontal, meaning the legend entries are going from left to right instead of top to bottom. So now if I want to use a different color scheme, all I have to do is create another column that indexes into a different color scheme. In this case, the MK12 color scheme from colorschemes.jl, from that package. So I alt enter here, and you could see the last column here, my color column, the second to last column was my oranges and purples, but the discrete color column, this color, my last column, is going to be MK12 colors. And then everything else is the same. I can just alt enter through the creation of the scatter plot, alt enter through the creation of the legend, where now for my color, I'm saying use discrete color, the discrete color, and then add the legend. And then there it is, added into the figure. So there you have it. We take full responsibility for the color of every single one of our points. Basic strategy is get an index for sequential data between 0 and 1, map to a data column, put it right in your data frame, and then just index into a sequential color scheme. For discrete colors, form a categorical array, which behind the scenes really represents every string as an integer. So all the unique integers get a unique, or all the unique strings get a unique integer, 1s and 2s, and then just index into a color scheme. For sequential data, we have to tell Makie about our mapping in 2 places. 1, our mapping for the scatterplot itself, and 2, our mapping for the color bar. For discrete data, again, 2 places, the scatter plot again, but instead of a color bar, we take control of the legend. And there you have it. That is owning your colors using Makie Array Attributes, or the color array attribute in Makie. And if you enjoyed this video, please like and subscribe.